So let us try to go through this paper, right? You can see my screen, right?
Yeah, I can.
Yeah. So I think, so I think I'm going through this derivation which you had sent, right?
Mm-hmm.
Regarding derivation of local volatility, right? So let us go through it one by one. Like we would want to expound on it, right? I mean, not only go through mechanically the equations, but then
Mm-hmm.
try to find meaning of the things within that, right? So I think the first equation which they have here, right, is this evolution of stochastic process of how stock evolves, right? Which, in my personal opinion, is somehow incorrect. Okay, and I'll tell you the reason for that. Although it kind of doesn't matter the way it is structured, but I think it is incorrect. Okay, so what they've done is they have said that ds is equal to mu dt plus sigma s st dwt, right? Generally, mu is used to represent the drift, right, of the geometric Brownian motion. And generally, when that happens, right, we are talking about a stochastic process which is evolving in the natural probability measure, right? Which I don't think is what is being referred to in this complete paper. So they are referring to the risk neutral probability distribution, not really the natural probability distribution, right? And which is why I think I somehow don't agree with it, uh, assuming that this is the drift and not the risk-free rate. Okay, if mu refers to risk-free rate, then kind of this is right, but it refers to the drift, then maybe this representation is not right. What do you think, Sam?
Yeah, I agree with you.
Yeah. So I mean the way this call option is defined, right? So call option is defined as, so I think we are kind of aware, right? So PDT refers to the discount factor and expectation of ST, which is terminal stock price minus K and plus, right? So this essentially refers to max of ST minus K, and we take expectation. That expectation is under the risk neutral probability measure, right? Not the natural probability measure, correct? Which
Mm-hmm.
brings us to this equation of PTT, right? Integration from K to infinity, ST minus K, ST, right? Just give me a minute. Hey, hi Praveen. So this brings us to this equation of, call option price is equal to like PTT, right? Which is the discount factor, and integration from K to infinity, ST minus K, FST TDS, right? So F
Yeah.
essentially refers to the probability density function, and it is the risk neutral one. We are integrating it from K to infinity because from 0 to K, right, this function itself becomes 0. So it has no value add in that sense, right? But we'll come back to that point of 0 to K because it's very, very critical at a certain point in time, right?
See, 0 to K, your call value will be zero, right?
0 to K, the value of option will be 0, right? But 0 to K, the
Yeah.
value of stock price will be there, right? What I mean
Yeah.
to say is that uh, probability density function still, risk neutral probability density function still exists from 0 to K, right?
Okay. Yeah, it would exist,
So you
but it
can
adds no value.
no value to the option, right? But
Yeah.
if someone is interested in finding the risk neutral probability distribution of the stock, right, from 0 to infinity, right, then it would have
Mhm.
pretty much value, right? I'll come back to that point, and that's very critical point, right? For example, okay, so what they have done is if you differentiate the call option with respect to strike, right? So essentially we have this equation, correct? This equation which is getting differentiated with respect to strike, right? The first part is not related to strike at all. So we just take it out as it is, right? And we are left with ST minus K. and then the probability density function of S and T, right, is not dependent on K. That is why again we keep it as it is, and we only differentiate this part, which is St minus K, right? When you differentiate with respect to S, that is 0. With respect to K, it is minus 1, and which is how we end up with this, right? So any questions so far, Mayur or Praveen?
No question from my side, Ajit.
Okay. So like numerically, uh, this looks interesting, right? But like I said, Sam, right? We can have something from 0 to K as well, correct? And in that respect, this comes in pretty handy, right? Now, someone on the call, right? What is the integration, right, from 0 to infinity fst ds, right? If the limits of this integration, if I change instead from K to infinity, if I make it from 0 to infinity, right? Can someone tell me what is this expression if we integrate it?
Hmm. 0 to infinity. So if you even do to 0 to infinity, I will split it into two parts: 0 to k plus k to infinity.
Why?
K to
Because
infinity.
no, but
I
K
mean,
does not
just to
come into
simplify.
picture at all, right? Because we are not no longer talking about the option now. We are only talking about stock price, correct?
Okay, is it like 0 to infinity f of st comma ds, right?
Yes. So this is where the fill in the blanks or gaps comes in, right? Because paper states it in a certain fashion because they have a certain objective in mind, right? They have option volatility in mind, right? That is why they are not bothered about what happens between 0 to K. But given that we are trying to understand what's happening, right? Is it not a valid question to ask what happens between 0 to K, right? If we integrate or whatever 0 to infinity FST DS.
I would believe you will still get an expected value of a stock, which might deviate from the call value.
But where is stock here? There is no stock here, right? If I were to
FST
say,
represents.
yeah, if I were to say this is integration from 0 to infinity S into FST DS, correct?
Okay, yeah.
Then you will have expectation. But if it is only integration from 0 to infinity FST DS, right? Then what
Will
will
it
you
be
get?
one?
Exactly. Because it's a probability, right?
It's a CDF, yeah.
Yeah. So probability, I mean, so this is a PDF, okay?
Yeah,
This
yeah.
is a PDF, this is a CDF. From K to infinity, it was not talking about the CDF, but this is a PDF. So if you integrate the PDF over the complete interval, correct, of the stock price, then you get one. Okay. Now this stems from the fact that if you sum over the probability of all the events, okay, of the sample space, you get one, right? For example, again I'll simplify it for the other people, right? So if you have a die roll, right, and if I ask you what is probability of getting either 1, 2, 3, 4, 5, or 6, right, then the probability is 1, because if you throw a die, you're going to get something out of it, and if you find the probability of sample space, then it is 1. So that is why this equation becomes interesting, right? I can rewrite this equation as, okay, instead of from K to infinity, right? So this part, okay, only the second part, which is K to infinity fstds, okay, this is equal to, or this plus integration from 0 to K, right, fstds is equal to 1, right? Therefore this part K to infinity fstds is equal to
1
1
minus
minus of that, right, whatever K.
0.
So 1
Yeah,
minus of integration from 0 to K fstds, right? And
yeah.
since there is a minus sign here, okay, and if I take that minus sign to the other side, right, so what happens is you get integration from 0 to K fstds minus 1, correct? So let us keep that in mind, okay, and let us try to do something around that. Okay, now why are we delving deeper into this, right? In derivation of local volatility, right, there are three major parts, right? First major part is these derivatives, right? So the first derivative gives you a CDF, the second derivatives, again this is elementary calculus, this gives us PDF, probability density function, correct? So this is the first part to it. Second part is, we have a Fokker-Planck equation. Okay, now let us try to understand what Fokker-Planck equation means, right? And in that context, what are we doing with the probability, right? So if FSTT, right, is the probability density function of the underlying stock price ST at time t, right? Essentially what it means is at time t, right, with each stock price, whatever it can be the outcome, okay, whatever stock prices values it can take, what is the probability associated with that, okay? For example, let us say currently S&P 500 is at 4,500, right? Now at t, right, that is, let us say t equal to 1 day, so let us say tomorrow, right, it can take all possible values, okay, st from 0 to infinity. Now with respect to each of that stock price or underlying price, what is the probability associated with that, right? So that is the probability density function essentially, right? But the Fokker-Planck equation in general is about the evolution of that probability density function, right? As the time goes by, how does that probability density function change? So that is given by this equation. Okay, essentially what it means is change in probability with respect to time, okay, is equal to minus of change in the first factor, right, which is mu times s f st, right? This comes from this equation, right? That's what I'm presuming, plus half dou square s by dou s square into this, right? So essentially if you have a probability density function, this total probability density function at a time, okay, how is it going to change over a period of time? That is what this equation talks about. Okay, so local volatility model derivation, right, it starts with the derivatives of call with respect to strike, first derivative, second derivative, and time. It goes into probability transition, probability density function, how it transitions with respect to time, right? And finally it ends up with giving us what is the volatility, local volatility at any instant, right, of S and T, right? So the final outcome is volatility, but it goes via the probability density function approach, correct? So it is very important to understand numerically or have an intuitive understanding of what this probability density function means, right? Which is why we are going to expound on it, right? We are going to extrapolate on it, go ahead on it, right? And try to understand what is happening here, right? So now we have this part, right? We have this part, right? Now let us try to look at certain data set, actual data set, okay? For ease of simplicity, right? I'm slightly comfortable with, I'm biased towards NSE. So I'll just go there and look at their option chain. It's just that that I'm easy. I mean, I find it easy. I'm referring to it. Otherwise, we could have referred to anything else, right? What I'll do is I'll export, download this as CSV. Let me do something. This is 3rd December, right? Let me take 1 month expiry option. Yeah. Okay. Now this is what we have, right? So as per this equation, right? If we do dou c by dou k, right? We are supposed to get minus, pt, right? Integration from k to infinity fstds, right? So I think it is rearranged somewhere. Yeah. So integration from k to infinity fstds is equal to minus 1 by pt, right? Ptt dou c by dou k. For sake of simplicity, we'll assume that this ptt is equal to 1, okay, for just for calculation purposes, okay, so we'll ignore it for now. So what happens, right? What all we have to do is take minus dou c by dou k, right? And we should end up with the cumulative probability distribution function for S, right? Let us try to do that. Now we have these strikes. Okay. Let us try to see where the Bolinas changes, which will be important for us at a certain point 20,250. I'll just highlight this, right? So what are we trying to do? What we are trying to do is minus dou c by dou k, right? So first let us take dou c by dou k is equal to, right, change in, okay, let us see what is the last traded price. This is the one, so let me just freeze the top row. Okay, so is equal to minus of, let us, someone else is also joining, admit. Okay, so let us try to find out what is dou c by dou k, right? So dou c is change in call option price divided by change in strike. This should make difference. Is there something wrong with prices? Can someone help me out here?
F73. Let's see.
Or are we wrong with the numbers?
You 261.
So okay, let us go step by step, right? Let us first take dou c, right? Let us take the difference in the call option prices. I think this doesn't make sense. Yeah, this doesn't make sense, right? Because can someone tell me why this doesn't make sense?
Negative.
No, not for the negative part of it.
73 minus.
It is getting into the money.
Sorry.
It is getting into the money at that strike.
So can someone tell me what is wrong with W73?
Ajit, sorry, I joined in a little late. Can you just give me a brief rundown of what am I looking at and what's the formula?
Yeah. So essentially what we are trying to do is at the first part of equation, right? What we are trying to do is we are at dou c by dou k, right? So I think Sarthak, you have gone through the derivation, right?
No, not yet. Not in depth.
Okay.
I've gone through the paper and the Goldman Sachs thing that you've sent.
Right, right.
Not in depth of the derivation.
Okay. Not really required, right? So we have just covered so far only three steps. Okay. For example,
Okay.
first step is call option is equal to, this is essentially a present value. So this is a discount factor. For sake of simplicity, you can ignore this for now, right?
Okay.
This is equal to expectation of st minus k, okay, and plus sign.
Okay.
You understand, right? It takes max.
Yeah. It's the max number. Yeah.
Yeah. So if you, so essentially you are integrating it from k to infinity,
Okay.
and the reason for doing that is anything beyond k, right? Anything beyond, I mean less than, so anything 0 to k, right? This is going to be 0, right? St minus
Yeah,
k,
makes sense. Yeah. So no need to add it.
right? So when when we take the first derivative with respect to strike, right?
Okay.
What is happening is this is not a function of strike. Okay, so it stays
Yeah.
as it is. This
It's a
is not a
constant.
function of strike. Okay, so this also goes away. Okay, so this becomes 0.
Okay.
This becomes -1, right? Which is what you see here. And we end up with this. And this essentially is the probability density function.
Okay.
Risk neutral
So basically, we are integrating over a probability density function from k to
infinity.
infinity.
Yeah.
Yeah.
And if you
And the
integrate,
negative t p at sorry, the negative. I think the p is also a probability function.
no, P is discount factor. Uh, so it is something, for example, if you have 10 rupees 1 year from now, right? What is present value of that? In that
Okay. Okay. So we can ignore this basically.
for now, we
Yeah.
can
For
do
now.
it, but for now we'll ignore it. Okay. Now what we're trying to do is we are trying to now you understand that this is a CDF. Right?
Yeah.
So we are trying to find what is cumulative probability risk neutral density function of a stock from a live data.
Okay.
Okay. So this is Nifty option chain. I've simply downloaded it. Okay, from net. Okay. What we're
Okay.
trying to do is we are trying to find what is the same thing. Okay, risk neutral probability. Okay. So if you put it in words, right, this equation means the risk neutral probability that the stock price will be greater than or equal to strike.
Yeah.
Okay.
Basically, if this was a normal distribution, you are more concerned about the tail case.
No,
Like we are
no,
concerned about what's happening to the right? That's why we are going to infinity.
no. I'm looking at the complete distribution. Okay.
Okay.
Essentially, I want to find, for example, let me come back here. Okay. I want to find what is the risk neutral probability that the stock price will be greater than or equal to 20,250.
Okay.
This is, remember, this is not a natural probability. This is a
Yeah.
risk neutral probability. Okay. So the question, so we have this data, right? So
Yeah.
if we are numerically trying to do dou C by dou K, which we can do, right?
Yes.
Dou C by dou K should give us, okay. So we are trying to go step by step. Okay. First we did dou C. Okay.
Yeah.
Change in call option price. Okay.
Okay.
Now we are going to divide this by K. Okay. Change in K, which is 50. Right. 20,200 to 20,250. Right. So change in strike is 50. Okay.
Yeah.
Change in call option is 60. Okay. So can you tell me what is wrong here with this data? This is important learning for us as well. Okay. It's not as if we are going to get clean data set each time, right? So it is important for us to understand. Sometimes we might get, you know, some data quality issue, right? That's how I would want to put it. Not good
So,
data. That's what I'm putting it.
okay. So this is so. Just a final question. The final that is boxed right now, where the formula is,
Yeah.
that's your dou C by dou K.
No, that is only dou C, which is
Okay.
change in call option price, right? Because dou K is, I think, evident, right? This is 50, correct?
Yeah.
This is strike. Change in strike is 50, right? That is,
Oh yeah. So we can manually add it.
yeah,
That's not an issue.
yeah. But here what we are saying is change in call option price is 60. Okay. So can
Okay.
someone tell me what is wrong with this data set?
Mm,
There is something wrong, okay? Because let us do it, okay? So for example, you have minus dou C, right? Uh, I showed them just now. I'll just do minus, yeah, okay.
so just a final question. What was the exact like? Why are we considering this to be a wrong thing?
Yeah, yeah, that's the point, right? So this is dou C by dou K, okay?
Yeah.
So this is probability.
Okay. So we are getting negative probabilities.
Negative probability
That
is
should not be in.
negative
Okay, but
probability is
probabilities in general cannot be negative.
and plus greater than 1 and all, right?
Yeah. It has to be between 0 and 1. So that's the error. Okay.
Yeah.
So the issue must be with the subtraction part of things, or maybe
Like, see,
some.
even if we assume that our negative numbers are positive, right? That's how our sign could be wrong, right? We can come
Okay.
back to that later. but still we cannot get any number more than 1.
Yeah, but we are getting a 1 number here.
Yeah, that's the bigger problem, right? Signs, of course, we can check what we subtracted from what, right?
Yeah, but 1 should not be there.
Yeah.
So I'm just looking
So
at.
that's exactly what I'm asking. What is issue with this data? Can someone think? Okay. If not, I'll just answer it in a minute. Okay. But I want you to brainstorm, okay? Because this will help you later when you see the
Is
actual.
there a connection between the OI column, the very first column, that has 30,000
No,
numbers in it?
you don't have to look at any other column. We are only
Okay,
concerned
so
with column F and column L. That's all.
okay.
I mean, indirectly it is related to OI, but not directly.
Okay.
I mean, mathematically we are trying to walk it through, right? So mathematically we are trying to understand what is issue with it. Someone
Okay,
on
there
the
is
call-
another -1 on the second line.
Yeah, yeah.
So I'm just looking at where are we?
Can someone on the call can think through this? What's happening here? So essentially, what's happening is if you look at an option price, right, it has two components to it, right? It has intrinsic value and it has time value, correct?
Yeah.
Now, the if so, for example, change in strike is by 50, correct?
Mm-hmm.
So change in option cannot be more than 50, right? Because option changes at the most, if it is completely in the money, right, it will change 1:1, correct? But
Okay.
if it is changing more than 1, then there is arbitrage here, correct? That cannot
Okay.
happen because option is a, again, a right. I mean, it's not an obligation. You can exercise the contract and so on and so forth, right? I hope everybody on the call gets this point, right? So if so, intrinsically, the option cannot increase by more than 50, right?
Okay.
Whatever time value is there, that is same for all options because the strike is same and time to expiry is same. I mean, strike is different, but time to expiry is same. So time value of money is constant for all of them. Constant in the sense, you know, not. I mean, it depends on strike. But the point I'm trying to make is
The change is constant.
intrinsic value which is jumping between two. Okay.
Yeah.
Where does intrinsic value come from? Max of S minus K.
Yes.
So that value when strike jumps, right, and S is same, correct? Then that value cannot change by value of more than S minus. I mean K2 minus K1.
Okay.
Correct. For example, what I'm trying to say is at expiry, right, this option will have a value of max of S minus K, correct,
Yeah.
comma 0, correct.
Or 0. Yeah.
This option will also have max of S minus K, comma 0, correct. Now if I take difference of these two, right, and again for sake of simplicity assume that both of them are not 0, okay, although one is at the money, one is in the money, one is 0, one is non-zero, okay.
Yeah.
Only for sake of simplicity, if we assume that both of them are non-zero, right, then this is S minus K1, correct. This is S minus K2, correct. Then when time to expiry is exactly 0 at expiry, right, the difference of the prices in this contract will be K2 minus K1, correct,
Yeah.
right. It cannot be more than that. Now before expiry, the prices of these respective options are even less than S minus K1 and S minus K2, correct. Then it has to be even lesser than this, right. That is why
Hmm.
this is a data quality issue which you can encounter in the data set. Okay.
So Ajit, I get where the problem is coming from, but why is this a data quality issue?
Data quality issue because, okay, now the last, so if you can see your bid and ask prices, okay,
Yeah.
there is a huge difference between them.
Okay.
Okay. Now essentially we are saying the last traded price is equal to bid price. Okay. Very technically speaking, okay, price is something between bid and ask. Although you cannot exactly tell what is that, we can take a midpoint or something like that. Okay. But it is between bid and ask.
Okay.
Okay. Now again we are sourcing a free data set, right? So they are not bound to ensure that the quality is good and all of that, right? They just have a data set which they try to maintain the quality of it to the maximum possible extent, but they are under no obligation to provide us good or correct quality data. I hope you understand what I'm saying, right?
Yeah.
And hence what we'll do is we'll do something else, right? We'll go to the same website and we'll pick up another option set. So this issue will not face if you're working for someone, right? If you're working for an organization, you will get a much cleaner quality data. Okay. So maybe let us take another expiry, right? 2014 or something like that. Okay? And hope that this has more liquidity.
Okay, I have a very noob question here.
Yeah.
Is there a relation between bid and ask? Like, sorry, bid of the next day versus the ask of the last day?
No,
No, right?
no. It is simply supply and demand. So
Okay.
there is no. I mean, this is people what they are saying, what they are ready to buy and pay and all of that.
Okay, so this is complete market randomness.
Yes, market driven thing. So there's only so much you can do about it.
Yeah.
Okay, let us try to see what's happening here. I would want to believe the last traded price, right? I don't know why that got frozen. Different speeds and different speeds. Okay, different speeds and different speeds. Okay, so we are looking at 20,250 for that matter, right? Yeah, this last traded price maybe like looks better. So minus of, so we have to keep in mind the order. C after minus C before divided by K after minus K before. Okay. Here also we have some, greater than ones. Okay. But like we have seen that that's a essentially a data quality issue. Okay. Now can someone tell me interpretation of this number 0.61 in context of this?
It is relating to the probability density function.
Yeah, but how do I read out numerically this number 0.61?
This would be the mean expected value of 0.65 would be the, I think, the mean of it. Or
No, like I said, right? It's not expectation. What
okay,
what
this is
how do you
so the
represent this?
whole density is 0.6 then.
Yeah, but how do you put it in words, right? What do you mean by whole density?
Is that dosy by Doke giving you the accumulative value of risk probability density for that particular strike?
Yeah, but again, what does it mean? How do you put it in words? So, for example, 0.61% is probability of what?
The prob. This. Could you go back to the formula, please?
Yeah, this is very important.
So we are integrating over k to infinity of the function strike. By the S. Okay. The probability function itself is between strike and time, right? That's what T stands for here.
Yeah, T is time to expiry. F is the
Okay.
strike price at expiry. That's what we have here.
60 is it like 61% probability that this stock value will go above strike?
Yes. The way you
Okay.
read this
Yeah.
is the probability. Okay, and let me be more specific, right? The risk neutral probability that the stock price is greater. By stock price, I mean the expiry stock price. Okay, we have to be specific. Expiry stock price is greater than strike
60. Okay.
61%. Okay, I hope now this makes a lot of sense.
Yeah.
Okay, now as you might have seen, every 50th step, okay, generally has low liquidity and those issues, right? Let us look at the data. Okay, this is 19,900. Okay, 19,950 has low liquidity, correct?
Hmm.
By liquidity, I
Yeah.
mean open interest. Okay, so
Yeah.
the likely last traded price is, the probability of last traded price being wrong is much higher if your strike prices are 50th multiples, correct?
Okay.
So this is just the market microstructure. Okay, different markets will behave differently. Okay, it is just the market microstructure that it is that way. Okay, you can't do much about it. The point is, you can kind of ignore what's happening. Okay, now, okay, now, now, can someone tell me, going this way the probability is going to increase, or going this way the probability is going to increase?
To the top, I would expect it increasing. As time
Yeah.
is going on, your probability should decrease.
No, no, no. This has got nothing to do with time. Okay, time is constant here. Okay, we are talking about same expiry. Okay, and we are
Okay.
talking about same expiry. So time does not come into picture. What we are talking about is,
Okay.
as strike is changing, what is happening? Okay, for example, my question is, which is more likely to happen? Okay, that the option,
Option closer
no,
to
no,
strike.
currently we are talking only about the underlying stock price. Okay, we are not talking about the option so far. Okay, now
Okay.
which statement is more likely to be true? Okay, the probability that the stock will end up about 20,300 is more likely, or about 20,200 it's more likely?
Hmm. At that stage, I think 20,200 is more. Wait, we're at 250, right?
Yes.
Yeah. So it's more likely to go down than it is to go up. Is that the logic?
No, 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 no. Okay, so I think we need to brush up some basics. Okay, we are talking about risk neutral probability. Under risk neutral probability, stock price evolves as a martingale.
Okay. So
Okay,
it has no memory of the past here, right?
that is not, again, I'm not talking about Markov process. I'm talking about a
Okay.
martingale. Okay,
Okay. Okay.
I'm not talking about what.
So basically, the world is fair.
Yes. Okay,
Yeah.
so I mean, in that sense, okay, in that sense, uh let us say, like, stock price is behaving like a random walk, right? So all the information because of which stock price would have gone up or down, okay, is currently has been priced into the stock, correct? And hence, herefore, the stock movement is going to be a random walk, correct?
Yeah.
So something which it has already crossed, right? It has already crossed 20,000. It has already crossed 19,000. Okay.
Yeah.
So that is a done and dusted fact, right? So by the time of expiry, the probability that it would have gone through that, okay, is still higher. You get my point? Something
Yeah.
milestone which has already achieved, the probability that it would stay at the achieved state is higher. Okay, in the same
Okay.
breath, okay, possibility that it will achieve a much higher milestone is much
Is
lower,
less. Yeah.
correct? That is logically understandable. What is
Yeah.
most
Makes sense.
likely? Most likely it will stay where it is.
Yeah.
You get my point?
Yeah.
In terms of probability density function, this is most likely to happen, and in terms of cumulative probability density function, this is most likely to happen. And
Okay, makes sense.
the more you keep going below, that is more likely to have happened. So now, like we have established that 50 multiples are less credible, right? So let us look at 100 multiples, right? So the probability that the stock ends up above 19,900, again, I'll not re-repeat my words, right? Risk neutral, expiry,
Mhm.
all of that, okay? The probability that stock ends up above 19,900 is 82%, correct?
Okay, yes.
This is an incorrect probability, correct?
Oh,
It
yeah.
cannot be
Yeah.
more than one,
Yeah.
right? Let us try to revise it, okay? Maybe let us try. So as you can understand, we can take three risk neutral probabilities. You can take last traded price, you can take bids, correct? And you can take asks. Or third thing is you can take midpoint of bid and ask.
Okay.
So let us see what is this. So this is 60%. So this is more understandable, correct?
Yeah.
This is more likely to occur. So this is more likely correct. Okay. Now let us look at this. Okay. Now this is more likely to occur. Okay. But this is inconsistent with this and this.
Yes.
Okay. So this function. Okay. Now if I plot it, when we are trying to do wall surface plotting or modeling, right? We are trying to ensure no arbitrage wall surface. Okay. For example, this will lead to an arbitrage. All I'm trying to say is, if you use these option prices, then you use Black-Scholes
Yeah.
models, then you generate implied volatilities. Okay. And if you simply plot them that and call as wall surface, that is an incorrect wall surface. You're getting my point?
Could you repeat?
So you have these option prices.
Yeah.
Take this column as option prices. You take these strikes, correct? Then you use the Black-Scholes model. Okay. From that, you calculate the implied volatilities, like you see here. Okay. They have done under certain assumptions, but essentially our job as quant is to generate these implied volatilities. Okay.
Okay.
And if you simply plot it and say that this is my wall surface, correct?
Yeah.
That is a wrong wall surface.
Okay.
Okay.
Because we don't know the assumptions. Why is
No,
it
no, no,
wrong?
no. That has got nothing to do with assumptions. That has got to do with consistency. Okay. If I say that the probability of the stock will be greater than 20,250 is 61%. Okay.
Okay.
That it will be greater than 20,200 is 78%. Okay.
Okay.
That it will be greater than 20,150 is 60%. Does this make sense to you?
Yeah.
How does this make sense? This probability cannot be lower than this probability, right?
Okay. Wait. Yeah. I saw it.
Okay. Then
Mm.
this cannot lie in between these two. This is not a monotonic function, right?
Yes. Then it will. Yeah. Right.
So this requires some data cleansing, some logical, consistent thing. You get my
Okay.
point?
Okay. But isn't this the column in which you did ask and bid thing?
Sorry.
This is the column where you no this that particular value that is not consistent.
Currently, we are referring to last traded price.
Okay, but there was one column that you manipulated using ask and bid,
Yeah,
right?
like I said, right? Then
Yeah.
how do you know where you need to make manipulation and where you not need to make manipulation?
Okay, so don't shouldn't the manipulations be consistent with the
Yes, it should be.
formula?
It should be.
Yeah.
Okay, it should be. But like I said again, right? So here you are getting 82%. Okay,
Yes.
here you are getting 50. I'll just change everything to percentage. Okay, here you get 82%. Here you get 55%. Here you get 64%. Right?
Yeah.
Here you get 75. So something is wrong here. This is completely non-monotonic.
Yes. This is not
So now our job is to make this monotonic.
okay.
Come up with any methodology. Okay. So any methodology in the sense anything which uses this data and these two data sets. For
Okay.
example, what you can do is I will completely ignore column F and I will take midpoint of bid and ask for everything.
Okay.
I'll make a new column. I'll say that this is midpoint of bid and ask, right? bid plus ask by 2, right? And I'll use this as my price, correct? And then
Okay.
I'll generate whatever, probability density function, my wall surface, whatever. I'll use this as option price and not the LTP.
Yeah.
Okay. So the point
Okay.
I'm trying to make is we are looking at one of the lowest quality data sets. This is not how you get a good data set. Okay. Bloomberg, Reuters will give you much cleaner quality data set. Okay. But at the end of the day, someone who is building the wall surface, it is his responsibility to ensure that his wall surface is consistent, arbitrage free wall surface.
Okay.
One of the checks which you can do to check whether your option prices are arbitrage free, right, is to plot dou by dou k, correct? If you
Okay.
plot dou by dou k, you are getting probabilities. Now you know all properties of probabilities. It has to lie between 0 and 1. It cannot be negative. It has to be monotonically increasing or decreasing depending on the strike, correct?
Yeah.
Right? So
Yes.
whether or not all these where these properties get satisfied, right? That
Mm.
logic you should be adapting. Okay.
Okay.
To be deciding on what option price is to be taken now, and then use that option price for wall plotting. Either it could be implied wall, local wall, or any wall. Correct.
Okay.
So this is such a simple thing, right? So our discussion has been centered only around this. Yet we are to go into much deeper or important things. Correct. But this
Yeah.
simple thing gives rise to so many logical tests, understandings, and all of that, right? For
True.
example, this is k to infinity, correct?
Yeah.
Now, if it is between 0 to infinity, right? I think we discussed it earlier. If this is between 0 to infinity, so integration of a probability density function over its domain, okay, is 1,
Mm.
correct?
Yes.
So if between k to infinity this is the case, then between 0 to infinity this is 1,
Yeah.
correct? Then you can also find what is probability between 0 to k,
Yes.
correct? So directly you can find what is probability that stock price will be less than or equal to this, right?
Okay.
You can have a cumulative distribution function, correct?
True.
So you can have a cumulative probability distribution function in that sense. Okay. Like I said, this derivation of local volatility has three main steps. Okay. And one very key central discussion, okay, is around change of probability density function with respect to time. Okay. The Fokker-Planck equation tells that if you have a certain probability density function, PDF, risk neutral probability density function of stock price at a given time t, right? How is it going to evolve over time is given by this equation, right?
Okay. That's one hell of an equation, but okay.
Exactly. So what essentially that means is, right, if you have these stock prices, okay, assume you don't have data quality issues, everything is good, okay, data is
Mhm.
very good and it behaves as per maths. So if you take this risk neutral probability density function, I mean this is cumulative. Let us go back to how to derive the PDF. Okay. So if you differentiate this, I think that's again a very standard exercise, right? So if you have a CDF and if you differentiate that one more time, you get a PDF, correct?
Yeah. Right.
Very standard maths proof. This is
Yeah. Pretty common. Yeah.
nothing uh, rocket science. So we are not. So essentially, what we are trying to say is, if you take change in this probability, right, and with respect to change in this strike, right, and again adjusting for the signs, then minus of this divided by this, right? So this is the probability that it will have this price, correct?
Uh, I think there was an issue with the formula here. It's showing 0.4%.
No. Why do you think that's an issue?
No, wait, because of the percentage thing.
No, I don't think that's an
Should
issue.
not make a difference.
No,
Okay, it doesn't make a difference.
right?
Oh yeah, both for percentage. Sorry.
Yeah. So essentially, dou square c by dou k square, right? So change of this itself was probability, correct? So this will
Yeah.
be of the order of 0.5, 0.1, whatever. Okay. That again you're dividing by change in strike. Okay. Strike is changing of the order of 50, correct? Then obviously your probability will be here, correct? Am I right or wrong?
Okay.
So essentially, these are point probabilities, right? So what is the probability that it will exactly end at 20,250? That is 0.4%.
0.4. Yeah.
Okay, and so on and so forth. Okay, I hope I'm right, right?
The double derivative will give.
That is what it says, right? So you'll have to differentiate. Okay, sorry, I'm wrong. I'm wrong. I'm wrong. I'm wrong. Okay, what this should be is not this or this. Yeah, that's what it should be. Because double derivative, right, is defined as, so how will we do this numerically? Correct? So it is derivative of derivative, right? So derivative with respect to k of dou c by dou k, correct? And dou c by dou k itself is this, right? So derivative of that, that is differentiation of this. Differentiation means you take first difference with respect to this, and then
Yeah.
again with respect to strike, right? Which is what will end up here. Okay.
Yeah, that makes sense.
So the probability that it will exactly end up at 20,250 at expiry is 0.4%, and so on and so forth. Correct?
Okay.
Now this is the PDF which we are referring to. Now Fokker-Planck equation talks about evolution of this PDF with respect to time. Right? So the left part, right, is what we have here. Correct? So we have, so sorry, not here, here, right? And this will keep evolving with respect to time. Correct?
Okay.
And this has to satisfy this Fokker-Planck equation. He has broken that up into how much is due to change in stock and how much is due to change in second rate of stock.
Yeah.
Okay, and it has to, some kind of honor this equation. Okay, so I think we are kind of close to the call, and we pretty much are at the end of it. And we can continue this discussion maybe towards the next call. But I think this is some progress that we have made, right? So we have established first derivative, second derivative. In the next, we'll go through the derivative with respect to time and just resubstitutions back into Fokker-Planck equation. So that should
Okay.
be easy. But then getting the intuition behind what's happening, right? It's really important. And then there is a lot to read between the lines, always, as always, right? So here also there were a lot of things to read between the lines, and the more we play with the data, we'll understand it better. I have also recorded this session. I'll share it on the group a little later, but I hope this session was productive for everyone.
Yeah. Ajit, one final request. This is the proper derivation, right, of the IV function.
Yes.
Can you just share it on the group?
Yeah, I have put it on the group.
I haven't seen. 1 minute.
I'll again paste it today.
Yeah, I think I must have missed it.
Yeah, I'll put it again.
Yeah.
Okay. So we'll continue our discussion on the chat and all. So
Yeah, sure.
thanks everyone for joining the call. Yeah,
Yeah, thanks a lot, Ajit. Yeah.
happy to help. Nice talking to everyone. Yeah. Thanks. Bye.
Thank you. Bye.